Today we're going to be solving inequalities, and specifically we'll be solving inequalities by using addition and also by using subtraction. So what you'll notice is as we go through solving inequalities, um, these rules for adding and subtracting, they're going to be the same rules that we followed when we solved equations. Okay, so here's the difference. Right? Equations have equal signs. They are things that are equal. They're equations. Inequalities, we're talking about greater thans. We're talking about less thans. We're talking about your greater than, equal to, less than, equal to. We could also be talking about your just unequal to, right? So these are inequalities. Um, a quantity on one side of an inequality and a quantity on the other side of the inequality, they're not equal, they're unequal. All right, so let's look at an example and we'll go from there. So solve, and then we'll check our solution. So x minus 12 greater than or equal to 8. Okay, so if this was an equal sign in the middle, okay, I think you would know that we're just going to add 12 to both sides of the equation, and with an inequality we get to use the same rule. Okay, we're going to add 12 to both sides of the equation, and we get x is greater than or equal to 20. Okay, so on a number line that looks like here's 20, okay, and greater than or equal to. The or equal to would mean this would be a closed dot, a closed circle, and then greater than pushes us off to the right. Now, we don't have to go into a lot of detail on number lines. Uh, bigger numbers, go off to the right. So 21, 22, 23, etc. Smaller numbers go to the left. I didn't mean to make that negative. Smaller numbers go to the left. So we're talking about 19, 18, 17. And so x greater than 20. We should be able to look at that number line and see that 21 is a number that's greater than 20. So let's say x equals 21 and see what happens to our equation. So 21 minus 12 should be greater than or equal to 8. 21 minus 12 is 9, and that is greater than or equal to 8. And so that's a true statement, which means that we've got our shading correctly. Now, if we picked a number that did not get shaded, 19 for example, 19 minus 12 greater than or equal to 8, right? We're just substituting into our equation. So 19 minus 12 is 7. 7 greater than or equal to 8? Not, right? So that is us checking our solution. If we pick a number in the shaded part of our graph, then it should give us a true statement. If we pick a number on the not shaded part of our graph, it should give us a false statement. We won't go through that checking every single time, but that's what checking your solution should look like. So let's do one more, and you'll notice this time the variable is on the right hand side of the equation, the inequality, and sometimes that makes us uncomfortable, so I'm going to show you how we can flip that around. Okay, let's solve it first, and let's solve it first by adding 8 to both sides. And so 30 greater than m. Okay, so again, most of us are going to be more comfortable, and then graphing is going to be easier if our variable is on the left hand side. So let's read what this says. This says that 30 is greater than m, and if we read it the other way, it says that m is less than 30. So that's what we do when we switch it. Okay, so the m and the 30, all right, we're going to switch sides. Our inequality is pointing at the m, and so it still needs to be pointing at the m. And all we've done here is we've switched sides of the inequality. Okay, don't have to make that step. It's going to make graphing a little bit easier down the road. All right. So this one is yours. Solve for D, and then remember that you can check your solution. So adding 14 to both sides, you should get D greater than or equal to negative 5. Okay. Let's try one more, I think. Yep. Try this one. All right, subtracting 19 from both sides. And so m is going to be greater than, trying to do it in my head real quick. 37? Are you okay with 37? We'll talk about it if you're not. M greater than 37. Okay. All right, now here's one that looks a little different. You'll notice we have variables on both sides of the inequality. In this example, they're both A's. And so think way back to when we first started solving one-step, two-step equations. One of the things we wanted to do first was to get our variable on the same side of the sign, on the same side of the equality sign, the equal sign. And so here we're going to say the first step still should be to get our variable on the same side of that inequality. And we'll do that by subtracting 3a from both sides. And so 6 is less than or equal to a. And that actually solved it for us, right? We didn't have to do any multiplication or division. Again, if I wanted to flip this around and write it the other way, the only catch is our inequality is pointing to the 6. And so when we flip it, it still has to be pointing toward the 6. 6 less than a still means that a is greater than 6. All right, you try 1. Okay. Subtracting 9n from both sides, and we get n, well, and I'll read it the other way, negative 1 is less than n, which means n is greater than negative 1. Okay. All right, we'll try one more, see how you do with this one. Okay. H less than or equal to 12. Correct.